Hello everybody and welcome to today's lesson on polynomial division. Our objectives for today are we will perform long division and synthetic division on polynomials, and we will use the remainder theorem and the factor theorem to factor higher order polynomials. But let's first go back and remember what are the parts of a polynomial. First, we have the degree. The degree of a polynomial is the exponent of the term with the highest exponent, and if the polynomial is ordered the way it should be, like this example showing here, that should be the first term. So in our example here, the degree is 3. Then we have the leading coefficient, and the leading coefficient is the coefficient of that first term with the highest exponent. In this example, that would be the number 2, the coefficient of the term 2x cubed. And then also very important in lessons to come soon, the constant. The constant is the term that has no variable with it. How do we divide two polynomials? We can divide the polynomials two different ways. One method is called long division, and the other one is synthetic division. And we are going to look at both these methods in this lesson, starting with long division. Let's first take a look at polynomial long division, and in order to do that, we are going to remember how to use long division in general for numbers. Let's look at this example. We want to divide 64,483 by 20. So how many times does 20 go into 64? 3 times. 3 times 20 is 60. And now we have to subtract that. Bring down 4. And we got 44. How many times does 20 go into 44? 2 times. 2 times 20 is 40. Subtract. We have 4 left over. Bring down 8. How many times does 20 go into 48? Another 2 times. 2 times 20 is 40. Subtract 40. We have left 8. Bring down the 3. How many times does 20 go into 83? 4 times. 4 times 20 is 80. And 3 is left over. Can we divide 20 by 3? Not without decimals. At this point, we're not going to go into the decimals. We're just going to note we have a remainder of 3. And that's how we do long division. You probably remember now. Essentially, we always divide the dividend by the divisor and then multiply the result by the divisor again and take the remainder, and we keep doing that all the way through until we get to the end of the number. Let's just keep that in mind, because that's exactly what we do for polynomial division as well. So let's set up our polynomial. We want to divide the polynomial x cubed plus 5x squared minus 7x plus 2 by the divisor x minus 2. So I'm going to put our dividend into the house, x cubed plus 5x squared minus 7x plus 2, and that's supposed to be divided by x minus 2. So now we look at the first term of our dividend, x cubed, and divide it by the first term of our divisor, x, and we get x squared. And now we take the result, x squared, and multiply it back by both terms of the divisor. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And now this binomial has to be subtracted from our polynomial that we are dividing. X cubed minus x cubed is 0. 5x squared minus negative 2x squared is actually positive 7x squared. And now we're going to bring down the next term, negative 7x. Looking at 7x squared minus 7x, the 7x squared needs to be divided by x, and we get positive 7x. And now we're going to multiply that back by both terms. 7x times x is 7x squared. 7x times negative 2 is negative 14x. And this again needs to get subtracted from the binomial above. The first two terms cancel each other out. And then we have negative 7x minus negative 14x. That leaves us with positive 7x. And we bring down 2 and do the same steps again. 7x divided by x is positive 7. Multiplying back, we get 7x minus 14. Subtract all this. 7x minus 7x cancel each other out. 2 minus negative 14 is positive 16. Now, taking a look at the positive 16, we see that we cannot divide that by x anymore. And that is then going to be our remainder. So our final answer, our final result of this division operation is x squared plus 7x plus 7. And the remainder we write like this, 16 divided by our divisor, x minus 2. And one more time, this is the remainder of our operation. Let's look at another example like this. Let's first set our operation up for long division. 3x to the fourth power minus 5x cubed. Please note that we do not have an x squared term in here, and we are going to put a 0x squared in here so we can continue with our operation. Afterwards we get 4x minus 6, and all this gets divided by x squared minus 3x plus 5. Again, we have to add a missing term so we don't get confused with our operation. Okay, then let's look at 3x to the fourth power, and 3x to the fourth power divided by x squared leaves us with 3x squared. Multiplying that back by the 3 terms of our divisor, we get 3x to the fourth power minus 9x cubed plus 15x squared. See, now we have an x squared term. That's why we needed that missing term. And all this gets subtracted. 3x to the fourth power disappears, and we got negative 5x cubed minus negative 9x cubed. Leaves us with positive 4x cubed minus 15x squared. Bring down the next term for x. 4x cubed divided by x squared is positive 4x. Multiplying back, we get 4x cubed minus 12x squared plus 20x. And all this gets subtracted. As always, the first terms should cancel each other out, otherwise we did something wrong. 15x squared minus negative 12x is negative 3x squared. 4x minus 20x is negative 16x. And we bring down our negative 6. And start our division operation again. Negative 3x squared divided by x squared leaves us with negative 3. Multiplying back, we get negative 3x squared plus 9x minus 15. Subtract everything. First term disappears. Negative 16x minus 9x is negative 25x plus 9. Always be careful with that double negative. And the negative 25x plus 9. We see that we cannot divide the negative 25x by the x squared anymore. So this entire piece is our remainder. So our final result of this operation is 3x squared plus 4x minus 3 plus negative 25x plus 9 divided by the divisor, x squared minus 3x plus 5. That's how we do polynomial long division. Now go ahead and watch the second part of this tutorial where we'll talk about synthetic division.